We have to prove 1 minus sin x over 1 plus sin x is equal to the quantity secant x minus tan x squared. Now, usually in trig identities, we want to convert everything to sines and cosines. The left side already has sines in it. So let's start on the right side, because we can rewrite the right side, because we can convert secant x and tan x into sines and cosines. So what is secant x? Secant x is 1 over cos x minus what is tan x? Sin x over cos x, quantity square. So all we have done is we rewrote. Now notice we have to combine these two fractions, 1 over cos x minus sin x over cos x. They have the same denominator. So we can simply write that as a single fraction, cos x, and the numerator would simply become 1 minus sin x. So that's what we have inside the parentheses. That needs to be squared. So this quantity has to be equal to that. How are we going to prove that? Well, let's go ahead and write this as 1 minus sin x quantity square over cos square x. And what is the numerator now? So notice cos square x could be written as 1 minus sine square x. Now, so I'm going to do that. I'm going to write the denominator as 1 minus sine square x. This comes from the Pythagorean identity, sine square plus cos square equals 1. And the numerator is 1 minus sin x quantity square. So these are two different things. And the reason we wrote like this is because we wanted to look like the left side, which is 1 minus sin x over 1 plus sin x. Now when you notice, you actually have two copies of 1 minus sin x. You only need one copy, which means one of those copies should be cancelled out with the denominator. And if you focus on the denominator, it's 1 minus sine square x. So that's the difference of two squares. So we can factor the denominator as this is like a square minus b square. So it would be a minus b times a plus b. And the numerator is 1 minus sine x quantity square, which is same as 1 minus sine x times 1 minus sine x. So notice one of the copies of 1 minus sine x will go away with the denominator. And this is exactly what we needed, 1 minus sine x over 1 plus sine x. So we proved. So this is equal to the left side. So to summarize, we wrote everything in terms of sines and cosines, and then this is where we took a step where we said cos square x could be written as 1 minus sine square x. And that's the thing that comes from practice.